कौन?
गंगा।
क्या बात कर रहे हो?
कहाँ?
um, all right. So Docker build was done, guys, but let me do this again for you. So uh, Docker compose build, right? No case case UI, because it's already built, so I think it will not take some more time anytime now, right? uh, well, I think it shouldn't take time because it's already built according to the previous image, but it's again 2 days again building, guys. So what I can do, I think let's say if I want to start it, right? So Docker compose up, right? UI here. Started UI recreated. Okay. So these three things are started, right? As per the then I will choose here how many things are there. UI is running, API is running, and this is also running. So I think I don't need this build again, but if it is going on, then I don't have any problem, right? You can work in this terminal. Okay, so everything is up, and if I do like Docker compose logs of UI, it now no longer says that file does not exist and all, right? So app/ui.py here is working, and if I am opening this local host, okay, if I am putting this local host here, alright, so this, right, if I do like localhost 8501, then I should see my UI, right? You can see whatever the Streamlit application I have built here, and it is there, right, on this port. And if I do whatever.
You never say that.
I say not.
Okay, some things is I think this error I am encountering, right? Why I am encountering this error? Let's see. Alright, here. I need to give it. Alright. Okay, UI container is running here. Earlier error database is not set. Problem noticeable token problem. What was happening that your UI imports this error checks for database error. Usually UI container will have that variable. Right, so is a 02, so we will continue first of all. The old database says what our latest output says UI is running. The PSO is like saying with the would fixing a compose file like because your UI code actually imports the DB, I would give the UI a database URL explicitly. Okay, so local file.ui to what I have to change. Environment database URL here. Okay, I can change that, right? This URL is equal to this post is SQL, right? It's like think radar, then it has radar password, the password, right? DB here, colon 5432 plus review radar. If I can give this, right? And now the UI has both API URL, database URL. UI, this is actually an important architecture observation here. You might have expected like UI, then HTTP to API, then API will talk to DB, right? But your code currently does something different because you will import get receive prediction get states. UI itself accessible accesses the database. So your actual architecture is like UI, HTTP, and HTTP, different things. So that's different from the cleaner architecture. Course script already calls this an architecture shortcut. So don't actually hide this fact while teaching. Okay. So why does DB work as the host name? The UI database URL would use, not the local host. Voice Composer internal knows this. Similarly, API container. So inside compose UI API and DB both are there. This is a service you are teaching. So now the test UI actual. Okay, and let's say if I change this now, right? It's still there, right? I need to again compose of DUI, right? Again, I have to recreate it. If I go to the now again, now it's not the error is gone, right, guys? So I already only have this review, right? Compose networking is good like this, so only one. If I give it one more review in the curl request, then it will go ahead, right? Like this. I can give this here. Okay. Now if I go this way here and check what is the number, you see now I have two positives, and the component will create and component network is good, 79 confidence, right? Please enter some text. I can do like LMA is a good subject, but goes with NLP only. If I make this, it's positive counting, but it's giving this less confidence here, right? Okay. So as we were discussing, guys, right? Now we will go for the next section of this our discussion. Okay. So idea was like container must be disposable, and data should be persistent. So how can we do these two things simultaneously? So make these two things happen, we need volume. This will work as a bridge between persistent data and our disposable container, right? So we will need volume as bridge. Okay. So we have to check the data before destroying anything, right? So let me type a command here, right? And if I do, okay, docker compose exec, right? So what I am telling, like inside this so I am telling like work with the docker application, compose application, right? This is what I am telling to the docker, and describe by I am telling docker, okay, work with the docker compose, which is described by the docker compose .yml file, right? Then exec means like you have to run the following commands inside a container, running container, not in the anywhere else. Okay, so we have to find running container, right? Let me write full command first, then I will explain you, right? What is this db? So exec means like we will execute the command inside the already running container. Okay, so this is very different from the docker run. Okay, so docker run, what docker run do? It creates a new container, right? But docker compose exec finds an existing running container and enter in it, right? So it will run in the inside a like already running container environment, right? Let's say our the database container is running. So what it will do? It will find the DB container, right? It will find a DB container if it is already running. Then it will run this. So DB is the service name we have in our compose application, right? So in our compose file. So execute. We are saying like, okay, execute the following command inside the DB service container. In this POSQL we are writing here is for Postgres command line client. Okay, so the Postgres have its separate command lines, commands and client also there. So it is called PSQL, Postgres command line interface there. Okay, then we have uRadar. U means like use this Postgres user, right? So user is our radar, right? User is radar. So this message our compose configuration also we what we did here. Postgres user is you see here where the user here radar, right? This is then D is saying go to the this review radar database, right? So D means connect to this database. So we are connecting to the review data database, right? And then select dash C, right? What dash C will do? Dash C means like we will execute this command, SQL command, and then exit. Okay. So let me write this command count asterisk from predictions is our table run name, right? Okay, let me run this. What happened? Okay, so this is something I need to figure out what is the error here. One extra command line argument select asterisk from predictions. Okay. Let me write this command again. Okay. Completely if I have made a mistake. So the command will be like docker compose, right? Exec PSQL u will be radar and D is radar. Right? C is select count asterisk from predictions. Okay, let's see this. So number of count, we have to count this 3, right? One row, or we say 3 only. 3 is the count, right guys? 3 is the count. It is the answer for us, right? So let's say suppose our table contains because you can see here that we have 3 predictions in the database already. Then select count asterisk from predictions. What it will do? It is asking that how many rows are currently in the prediction table. Okay. How many rows, right? So mathematically count of prediction rows must be equal to n, right? Because we are selecting all, so it is 3, right? So you can see like why are we doing select count asterisk here, right? Because we are creating an experiment that we want to prove that database before container destruction and database after container destruction must be same. Okay, so you see this is 3, right? So now what I will do, I will destroy the running containers. Okay, so docker compose down, you see container review radar is removed, API is removed, also database also removed, right? And network review radar also default is removed. So everything is removed, UI, API, DB and PG data, right? After compose down, everything is down, but our PG data, right, must be must persist after this, right? So what I will do that so because what we did that we declared here volume is equal to PG data, right? So we created the volume, right, and then we attached volumes to the Postgres SQL, right? You can see here. Where is this volumes here? We have attached to our Postgres data, right? PG data. So the volume has a life cycle, right? So volume has a life cycle here, separate from the container. Okay. So we can think of it like this, that container life cycle is like this. We will create a container, then it will run, we will stop it, and it will be deleted, right? This is the container life cycle. But volume life cycle is, you create a volume, you run it, you stop it, right? You delete it, right? But after running, volume remains. Okay. And what I will do is I will prove to you that containers are gone first, right? So docker compose ps, so you can see there is no container running like we before, right? So the important point is that all containers are gone. So did it destroy the database, right? That existed setup we want. So what I will do is one more thing, docker compose up d, right? It's all running now again, right? Now old container which were deleted, right, of database container, now what will happen? A new database container will be created here, right? But it will again connect to this same volume again, right? So it will connect to existing PG data, volumes USG, volumes is PG data, right? So it will be again connected to the same PG data, the DB container, right? Okay. Okay, then what I will do, I will check what I will do, I will query the database again, right? Same database. If I can, I get the answer same again, then it's a good go. You see, again it is showing the 3 count, right? So before and after is just the same, right? So container was destroyed and recreated, but the data remained, right? Why did this happen? Because PostgreSQL store its database files here, right? In this variable library PostgreSQL data, right? So our compose file says okay, volumes PG data like this, right? You can see. So what it happens, like what our PostgreSQL do, it will write database files into this folder mounted from the PG data. Okay. The container is merely providing the PostgreSQL process, right? The actual persistent database storage is in the PG data. Okay. So therefore container, after container delete and PostgreSQL process also gone, right? Container file system gone, PG data still exists in that case. The new PostgreSQL comes and the important distinction between container versus volume, and this is worth emphasizing while teaching to you, okay, is that a container will contain this. Okay, this is a container for us. What it will contain? It will contain some processes, its own file system, layer, right? Its network namespace, its own environment, etc. Right? It is designed to be replaceable. Okay, but what volume contain? Right? Volume contain database files, tables, indexes, while, etc. Right? So container is equal to compute, but volume is like persistent data. So this distinction appears everywhere in the modern infrastructure also, right? So if I run this command here for you, docker volume ls, you see driver and volume name, right? Mongo data and review data, PG data here you can see. So this is proving that exot driver volume name, right? Local is review data, PG data, you can see here, right? So this exact project prefix depends on your compose project name, right? Which is review jar, and PG data is this, and this proves that containers will be deleted, but volume will still exist, right? And if you are wondering like why it is like review data underscore PG data, so compose actually automatically names the volumes based on the project. Okay, so conceptually it is like project name plus volume name. Okay, so review data our project name plus PG data is the volume name. So this is like this. Okay, and our this YML file only says volumes PG data. So compose gives it a project scope name. Okay, so project scope it is, right? And one dangerous command I will teach you, which is now you teach the footgun here. So docker compose down v. Okay, so this is a command here. Docker compose down v, right? Don't ever run this command, right? During the difference is docker compose down means like approximately remove the containers and network, and we will keep the named volumes. Okay, while we do this flag, right? This means remove the container, network, and named volumes also. So when we do this, our PG data will also be deleted. Database will be gone, right? So why would we never use down v? Because during development, sometimes you intentionally want a clean database, right? For example, old development data don't need it anymore. Reset database docker compose down v, docker compose of the fresh PostgreSQL. So, but in production system, accidentally deleting percentage data is potentially catastrophic, right? So now why our line production that flag is a resume generation event, right? So every compose down will not erase every prediction, right? This is not a true statement because you have a named volume now, right? The more accurate statement will be without a persistent volume, removing the database container can remove the storage data, but with PG data, the volume, it will survive. Okay. All right. All right, so we'll continue. So API is stateless because what we do is we create a API container, right? It is a application code. If it dies, API will die, right? If you can create another API code, it's the same code, right? It is not changing, so it is same behavior again. It does not own the important persistent data. Therefore, API is stateless. But Postgres and PG data is stateful, right? It is like important. It contains some important application data in that case. Therefore, DB is stateful. Okay, we can freely replace UI API, while we need to treat like DB data with much more care, right? Okay. Alright, next part, guys, we have where compose setup becomes much more professional now, right? So here we have to parameterize the secrets, okay, because we want like more security in this case. All right, so the problem we are fixing here, our current compose file probably contains this, right? Here you can see what it contains. Postgres user is like hard coded everything, which is radar, right? And password is also given, database name is also given, right? This will work, but there is a problem. So docker compose YML file, right? If I commit this file, so password will be shared, which I don't want to share, right? So the password will go into the Git, which I don't want. So even if it's only a development password, right, this creates a bad habit. Okay, the better separation is like Git should have like compose file must only contain the structure and configuration, right? But local machine should have like in .env file we should have this actual values and secrets. From there we can get some values here, right? And .env will already is in the .ignore file, right? .gitignore. So this .env file, what I will do is I will update our .env file now. Okay. So our let me write this Postgres user, right, is equal to radar, like this, right, guys? And our password Postgres password equal to radar dev password, right? And Postgres db is equal to db name is review radar, right? And database URL is already we have this. It is will be not docker internal. It will be like this. Database URL is equal to PostgreSQL, right? Radar dev password at db, right? 5432 review radar, right? So this we are taking our variables from here to in the .env file, okay, from hard coded in docker compose file we are taking here, right? So for this demo environment, that is our local development credentials, right? In production, we will normally use a proper secret management mechanism there, okay, rather than committing or casually disturbing the credentials. Then we have this name of the database. This is the database URL, you already know, right? So previously what we were doing, like when Postgres SQL was running on our Ubuntu host, right? What we were doing, we were doing this thing, localhost 5432 everything, right? And so now PostgreSQL is another compose service. So therefore localhost is not our local machine, it is database. right? So this is why we are using db here. Okay, so db is a compose service name. So compose variable substitution. Now we have to change our compose database configuration. Okay, so we have to change that with to here, go into the compose. We have our database configuration, right? What I will do is change from this to postgres user. You can see here, right? And password will be like this. Okay, you can see here like this, and database also like this, right? You can see. So we configured it. So the important syntax is the variable, right? So we have, this is the variable here. Okay, and so come here, when we are using this variable here, so compose will read the value from the .env file. For example, we have this postgres user is equal to radar, right? So radar will result in this radar. So all these variables will be read by compose from the .env file. Okay, that's the case. And dollar variable here, substitution from DNV at the compose parse time. What is the compose parse time? This is very important technical distinction here. When we execute our docker compose up, right? So compose first will read our YML file and it will resolve the variables. Okay, so conceptually docker compose YML plus .env, right? It will goes to the compose interpolation mode. Then we will have final configuration. Then we will create the docker contents. So these variables are very important here. Okay. Also we have to different like API also, right? Database URL we have to differentiate here. We have to do database URL like this, right? So our API also configured now. Okay, now also health check we have to, I think, where is health check? Health check PG is ready, review radar, right? So instead of review radar we have to do different thing, and radar also, right? So what we have to do is postgres user, right? And dollar here also, and instead of radar what you have to do is postgres db here, and we have to put this dollar, right? So these variables will be resolved at the time of compose parsing time. Okay, all right. And this is better than duplicating values, because without variables like we have PG also one more thing, like it also like changes the maintenance problem. Like if we want to change the user, right, we just change the this .env file here, right? It will be every, like we don't have to change anything, right? Right, so that is what we have to do. So everything will reference from there. And we have to update this also, because this can be we can commit this .env file, right? So what we can do is here I can write like post trace user is equal to your users, right? Then we will have post grace password is equal to your password, right? And we can have post grace db is equal to like review radar, something like that, right? And we will have database URL is equal to our this post res SQL, right? Radar, and or we can say like your users, your password, right? At db 5432 slash rebuilder. That's how we can update our this file, right? Actual .env file we will never commit because it has our secret, but an example file we can commit, right? So that is it. And this .env example file is very, very helpful, because imagine that your friend clones your repository, right? They get docker compose.yml .env example, but they will not get .env, right? Because .env is in git ignored also. So your friend does like cp dot copy, right? .env example .env, right? They will copy that example file in their ANV, and now they will have the configuration structure they need, and this is the common repository pattern, right? And we have, let's check if it get ignored at .env or not. We have to confirm it is already has, so it is confirmed, guys, right? And okay, now let me run our docker compose up, right? Here, what happened? Oh, it was not okay. Docker compose up. Alright, everything is working, I think. Running. Healthy. UI is running. API is running. DB is running. I think it is here. What happened? I think it went. We will not care for this now. First of all, because everything is working for us, right? And the variables are resolved, right? If I check like resolved configuration, like docker compose config and I say head minus 30 last 30. So you can see here. So this Docker compose config asks that okay, show me the configuration compose has actually resolved, right? So as you can see here, environment database URL it is there, right? Network and many things is there. Postgres DB it is not showing. Password it is not showing, right? User it is read out, right? So what is here? If I go Docker compose here, is there anywhere I have directly used the user as radar? Is there any place? There is nowhere, I think, right? Okay, so everything is resolved. I think here you see this test is also resolved already. So it is showing the resolved things, right? Database URL is there, right? Okay, and right then important security note here, because be careful with like Docker compose config, because resolved configuration can contain secrets, right? So we will not paste the full output into a public live stream. Also, I am pasting it because it's local in my system. You cannot do anything with it, right? So if it is production level, we should not like show in its own stream, right? Okay. Now we will face another problem here, the development problem without bind the mounts. Okay, like when we edit API, right? File which is on host will is changing, right? But the container still has old code. Docker compose build, recreate the container, then wait. That is annoying, right? So imagine making 30 edits, you might rebuild 30 times, right? So that is why we have to like bind the mounts. The solution is in volumes. What I can do is just a minute. In API service, right, we have to create some volume also. Okay, so the syntax is a host path and then container path. Okay, so therefore dot source blend mount app source, actual file system becomes alright. So what I will do, guys, is here come to this okay, I will create one new file, okay, which will be like this. Whatever. Docker compose dot override dot yml. Okay. Whatever. Docker compose it is, guys. because it was not showing the Docker icon, so that is why I was confused. So right, so in this Docker compose override, this is just development only tweaks here, right? Like compose automatically will merge this file over Docker compose by YAML when present. Okay, so convention is like base file is equal to production secret truth, override is equal to local developer config, right? So what I can do is tell this about file, like, so compose automatically merges this file over Docker right, compose file, okay, .yml when it's present. Alright, so this is all about it, and what I will do is I will services and API, right, dash slash src app src. Okay, what this doing is it will this is the bind mount. Okay, this is bind mount here. Alright, so the syntax is like we have some host path, so you know this is like PI volumes dash src slash app slash src, right? So this is called the bound mount. The syntax is we have host path and the container path. So this is the container path and this is the host path, right? So therefore our dot slash src, right, it will bind mount to the container src. Okay, so our actual file system will become like this. We have our Ubuntu host. Inside this we have a review radar, right? Inside this we have our src. This src is mounted to our Docker container. Okay, what is the Docker container? Where it is? It is in the slash app slash src, right? Here. So what is the difference between named volume versus bind mount? So it's very interview concept. So named volume is like this. We had like this dash pg data, then we had where library PostgreSQL, then data, right? We have like this. So here Docker manages the storage, right? And we have to use it for the database data. But bind mount, right? Bind mount, we are explicitly saying choose a host folder. Host folder is this src, it will host that, right? Then we have our container folder, use it for the development source code, and the distinction is the named volume Docker manage the persistent data, but in bind mount we have to specify the host directory to it is great way for like live development. Okay, so API bound mount, right? So we created our override file, right? Here override file we have this, right? And whenever I edit the src folder here, this is the host folder, right? I am showing in here also this folder. Whenever I edit in this folder like API and all, right? Whenever I do this, in this folder, edit, right? So the API container sees the change immediately in that case, because container is here in this app.source, here app/, alright, that is why, alright. So override file I have created, right? So this naming convention is very important here for the override file. You see here docker compose.override.yml. So compose automatically will use this override file when it is present in the normal compose setup, right? So architecture will become something like that now. We have our docker compose.yml. This is the base configuration, right? Then we have docker compose override.yml. This is the development changes here, right? Then we will get the final development configuration. So base plus development override is the development environment final we get, right? So we have to separate the base and override, because development and production have different needs, right? In production we want like immutable image, so host source mount, no host source mount there, stable startup, right? We will not change in do any change in the code, right? In that case, so production command is there. In development we want live code edits, right? Auto reloads of the code, everything, right? Fast iteration, debugging, everything we need. So in production we need docker compose YML, but in development we need both docker compose YML plus docker compose dot override YML, right? This is a very useful pattern for us, right? Also we have to do one more thing here, is okay, one thing I forgot, like this is volumes. Okay guys, dot slash src slash app slash src, you see, alright, this is the volumes here. And after the volumes we have our command also, right? Fast API, right? Then we have dev, then we have src slash review radar slash api.py, right here. Then we have host, then we have this here 101.0.0 here, right? Then we have port, this is 8000, that's it, right? What I have done here, guys, so fast API dev, fast API it will use the fast API, start the fast API, then development, source review.api.py, it will run this file, okay? And then host will be local 010 anyone, right? And port will be this 8000. So it will override the CMD development mode, right? Auto reload the file changes here, because we are using the DEV here. Host 00 because 127.0.0 development defaults to 127.0.0.1, right? So day 9 reachable by no bit, right? So trap remembered here. So this is why we are using the 00 for, like anyone can reach it here, right? And next thing we have here is the UI volumes like this. Okay, I think I need to change the indentation here. UI here and volumes, right? Slash f slash f slash f the host slash f slash fp. Okay. So Streamlit already watches files, so mounting the source is enough for live edits, right? That is it. Alright. So here you see here the command, right? This will replace the image. Image is the normal CMD. So our production Docker file might have like this. You see here our production Docker compose file. What we have? We have this CMD. Where it is? Here it is, right? Here CMD cell. Where is it? Docker file. Here, fast API run like this, right? Docker run, but our development wants, this is fast API run, right? But our development wants fast API DEV mode, right? So because development modes automatically supports automatic reload, right? So the development we have to override with the development mode, so it will help the reload automatically. Okay. Fast API dev, this means like run fast API in development mode. That's it. And this is important feature for our because file, whenever file changes, right, it will detect the change and it will reload the application itself, right? So no image rebuild will be needed in that case. We are using this host 00 because this is another important networking lesson here. So inside a container, if your application listens to this local host like 127.0.0.1, it will listen only inside the container, right? But 00 means like listen to all network interfaces inside the container. So 127 was the container local, but 0 is the all container interface. Okay. It is reachable through published port, right? So that's sad. And our host can access then access like localhost 8000 through host 8000 container 8000. Then we have UI band mount because this UI volume like this. This means our host is the ./app here, and the bind mount is to container which is on /app/app, right? So if you modify like app.ui.py, right? If I modify this file here, the container immediately sees the new file, right? Streamlit already watches file for changes. So right, immediately sees the new file, and Streamlit already watches files for changes, so you don't need to explicitly configure an application reload command like fastAPI mode. Okay, so complete development here. Flow. Okay, so whenever we edit our files, bind mount, right, will use, and container will be reloaded. Fast API auto reload will there. It will update the API, and also Streamlit is a file watcher, so update the UI, right? No Docker build is needed for every code change. That's a huge productivity improvement here, right? So let me start now. Docker compose up d build. If I do this, you see like, because I have changed some configuration Docker files and want to ensure that images are current, right? So after the initial build, ordinary source edit shouldn't require rebuilding. So because the source is bind mounted, right? So I have to change something, and let's say api.py, right? Where is my api.py? In the source, I think, right? api.py here. If I go into the here title review.api and plus and plus. If I change this, if you are seeing here, you see review are only like this only, right? But I also change this review title here. You can see where was the title. I think actually in the actual case. No, it's not in the this. It is in the streamlit, right? It's in the streamlit, guys. Where is the title? Here. Okay. Here I am using this like this. Where is the api.py? Here. I don't need to change this. Plus here. Okay. I don't need to change this. Alright. So here only I have to change. I have changed it, and okay. It's all saved. Then important. If I check here now, you see there is no change, right? If I change this here, you see reload. After reload, it's just added the plus without like Docker Compose build, right? So if I check the Docker Compose logs here, Docker Compose logs API, right? Tail file. So application shutdown complete, finished server process, started server process, waiting for application startup, right? Application startup completed. Also, if I check the local 1000/docs, it's not so. No, it's not 850. It's 8000. Yeah, you can see here to the okay. So we don't need Docker build image, right? And very important production restriction here. Our override file is for development, right? We don't need want this development for in the production, right? So here this in Docker Compose override, you see this thing, source app source here, because production should generally run the code that was packed into the immutable image, right? So in development, host source will be bind mount to the container, right? But in production, we have source code. We will have our Docker build image, which will give us our immutable image, and then on this image we will run the container, right? Now we are finished with the technical implementation. Next problem: how the another developer know how to run this, right? That's where README becomes important. So we have to update the README also, right? So this is our multi commands, right? So what I have to do is I have to change everything. This is because what I have to do is run the whole stack with this command bash cp. You have to like copy, right? Copy the .env .example file from in .env file, in the env file, and docker compose up d. That's it. That is what all they need, right? If I run this, you see here they just need this commands. Okay, so and more things we can add here is like what after running this we have this UI, right, on HTTP localhost 8501, right? We have this, and we have the API docs, right, where we have them as HTTP localhost 8000 docs here, right? Okay, if you see here we have everything here, right? And now what we will do, we will add everything and create the post it on GitHub. Okay, and that's it. Let me add on Git here. Here Git add docker compose, right, .yml here. We are reviewing this. Also git add docker compose .override .yml, and one thing is docker file .ui, right? We have to do this, and we have app/ui.py. This also edited. .env example also, right? Also our readme file, right? readme.md here. Everything is mounted. We are not like you notice that .env not included here. That's intentional. We just don't want to publish our secrets in public, right? So if I do git status here, you can see on branch docker compose here, changes to be committed. .env docker ui docker file ui, which is this, and we have readme app ui and docker compose override docker compose. These 2-3 files are just green, which is changed, and this is right like this. Only these files we are adding, and now what we'll do, git commit 10 will message like a feature was like this, docker compose here, right, stack API plus DB plus UI, right? Health check, gated, startup volumes, then env parameterized, right? That's it. Commit it, right? Then we what will do, git push u origin, right? Which is the what is our feature we this is our branch, right? Docker compose. So git push will send the commits to the remote repository you see here, right? And the origin is like our remote git repository URL, right? This is shortcut for that. So you see git origin, u origin, right? We have to give there. And u is like set the upstream tracking relationship. So u is like branch you are pushing is u. So after this future git push will work, right? So here the final, okay, that is it. And what I can do, guys, is I can go to GitHub and look into our review radar, right? And if there is a branch which can be if I can create a PR here, you can see run it, whatever. It's a build like getting things, right? It's updated. Readme is not updated. So okay, I think it's not merged right now. So I have to create compare and pull request. You have to create a PR and create the pull request. Alright, and it will check if you have done some checks, then okay. Alright, and instead of in production .env will like we will have like our separate secret handling management system, okay? So production secret manager. So .env is just for local development configuration. So when we go into production, the Docker compose and everything will read those files from there, okay? All the secrets from the Docker manager, not from the .env, okay? And next.
যে খাবারের সেট খাচ্ছি খাবো আরেকটা সেটের আছে খাচ্ছি ওই দেশি বাজার এই ঘরে আছে আমি বাইরে চলে আসলাম না আমি ওর রুমে থাকছি ব্যাডমিন্টন খেলাচ্ছি ব্যাডমিন্টন खाली यार मुझे तो मन सही लगा हम दो तीन
Alright, guys, welcome again. We will continue something more interesting. So, common mistakes we can make, guys, is that like we can use localhost between compose services, right? Like, but it is not that like that, right? So this is probably the number one conceptual mistake we can have, right? Right? Suppose our compose stack is like this. Like we have this our compose network, right? In this network we have our UI which will talk to API and which will talk to DB. Each one have this its own ports like this. It's like 8000, DB is like 5432, right? So the service names are UI, API and DB, right? Now Compose will provide internal DNS, right? So API will have like this. API will have to talk to 54 to this, and UI will connect to API 8000 like this, right? Which is wrong, right? Because inside the API, database URL is something like Postgres, localhost, something like this, right? Because the inside API container, localhost means the API container itself. So it does not mean the Postgres actual container. So correct will be the database URL is equal to PostgreSQL : / the user, then password @db : 5432 / review. This is the correct configuration, right? For database URL. Okay. For inside API container, as I am showing you here, go to the API container here, and this is the database URL. What is the database URL in our UNI file? See, this is DB here, not the localhost, right? So DB is the service name, correct? So that is what I am saying. Because DB connect to the Compose DNS PostgreSQL container IP. Okay. So the mental model you should have is every container has its own network namespace, right? So local host in UI means UI container. Okay. Local host in API means API container. Local host in DB means DB container, right? So that is the distinction here. So there are three different local hosts. That's why between Compose services we have to use the service names, not the local host. Okay. So that is one conceptual mistake. So when our browser accesses a published port like localhost 8501, right? That's correct because browser is running on our host machine, right? So very useful rule is when inside container we use service name. When we are outside container we can use like localhost plus published port, right? Mistake 2 we do sometimes is depends on DB. Let's say this is depends on DB here, right? So you might think like API will wait until Postgres is ready. This is not necessary here, right? It primarily establishes the startup ordering only, right? So the start is not ready, like it may not accepting the requests, right? So that's the case, and health check solve this condition. We have to, this is depend condition service healthy, right? So that's health check. Where is the health check test? Here we have our health check also, I think. Here health check, right? So depends on condition service healthy. Health check is here, right? So procedure itself is asked, right, that are you actually accepting the connections or not? So test is command cell. PG is ready. If it is not, then it will not pass the test. It will return false. Then intervals, 3-second interval, it will out, and after 3 seconds it will time out of the 3 requests, right? Retry 10 times only. Alright. That is it. Somehow. Okay. Alright, so this is what we are doing, guys. Here, very important case, right? And service health is there, right? So now this means that we will start the DB, then we will run the health check. If it is healthy, not healthy, then it will wait. If it is healthy, then it will build the API or start the API. Till then it is not start, right? This is much stronger. So it matters in real life, because imagine your database startup takes 8 seconds. Imagine this, right? So if API immediately connects, then at 0 second DB starts, and API start at your 1 second, let's say, and API connects. DB is not ready, it is not accepting any request, right? Because it will take 8 seconds. So with the health check, till 8 seconds, API will not start, and it will wait. And even the health check aren't the only strategy. A robust application can also retry, like connect DB. If it is failure, then wait for 1 second, then retry, then wait for next seconds. Like it is like belt and suspenders. Okay, like this is often called the retry and back off. So production systems often have this infrastructure readiness plus application retry logic, right? Mistake 3 we can do, like compose Docker down V. We don't have to do this. When we down, just to use normal Docker compose down. It will not remove our PG data or database. If you do flag V also, then it will remove the data also. Okay. Then next mistake we can often do is this. When we edit compose YML file, but not the recreating the stack. When we like edit our compose file, right? Like port 9000, 8000, like this. But your your existing container is still running 8000, right? So you can say like Docker ignored your change. Docker did not ignore it. You are running the container was created from the old configuration, right? So we have to run the Docker compose up D and desired state is not equal to current state, right? So in that case, it will reconcile the difference. This is the declarative idea again, right? So now when we write our 9,000, 8,000, this describe I want this state. So compose will check the reality. Current state is 8,000, 8,000, but the desired state is 9,000 colon 8,000. So difference exists here. So what it will do? So compose changes the container mathematically. Okay. So this the hard of declared state. When we need build, this distinction is very important. The build we need is when change compose configuration. For example, ports environment depends on volumes, right? Usually Docker compose up change the Docker file. Then you need a new image. Okay. Docker compose up the build we need. Change the application source in a normal build image. So when you change the source file, normal image, right? Then we have to build. Without bind mount source code change, then image still contains old resources. Then build required. So Docker compose of the build is required. When you change the source without development bind mount, we generally don't need to rebuild. Host source bind mount will container CJ, it will reload it. Okay. If you change the compose by YAML file, so Docker compose up D is like enough. You don't need to build it. If you change the Docker file, so you need to build that. If you change source code like that, okay. Next mistake we do is Docker compose versus Docker compose. So this is Docker compose and this is Docker compose. Okay. So this one is the older standalone compose implementation. In modern implementation we have this. Okay, so compose version 2 is integrated as a Docker CLI plugin. Okay, so we already using it. We are not using this, right? So we will continue using the space version. And this is the old version. Don't get confused with this. Okay, both are same. Mistakes we do like code already allocated. Suppose something on Ubuntu machine host is already using, right? Like port 5432, the Postgres port, right? So Docker will say essentially I can't bind the host port, right, 5432 because someone is already using it. So same for these other ports 8000 and 8501. So our compose DB don't need this because our DB currently has database services, but no port like this. You see here. You see here in our database service here we don't have any port, right? Therefore, PostgreSQL is reachable by API DB 5432, right? But not export directly as host DB like this. So, mistake 7 we do is like secrets commit to compose by YAML. So we don't do this. Now, one exercise we can do, guys. To confirm that we learned something today, right? What we can do is this. Okay.